Hey guys, so this is 2.6, combination of all the transformations that we have learned in class. Remember that there is an order to it. We did the investigation, we did the thinking process already in class. So I'm not going to go through those, but what we found out was that the order has to follow from the first to the last. Now in this case, what A, B, C, D means is, hopefully you remember it, from the function notation, that y equals a f at b x minus c and then plus d. So a, b, c, d means you start with this one first, and then after the first one you do the second transformation on the first one, and then third one, and then fourth one, as you go, right? However, one thing that you have to remember of is that if you compare this one to the original form that we have right here, this one, is that b is factored out, right? B has to be factored out all the time. The reason why is that if you don't factor it out, your horizontal translation will be different. So in this case, if you just to use this as a horizontal translation, it says 4 units to the right? However, if you actually factor this -2 out, which, I'm sorry, not -2, 2 out, then this becomes actually the unit 2 units to the right, horizontal translation, 2 units to the right. So be really, really careful if you have something in front of the x and that is not factored out, then you have to factor it out, okay? So the right order is then starting from A and then end with D. Now, if you do so, then you should be getting this. Now, again, this was the f at x, I assume, and this is the g at x, right? That's what I told you in class. So, knowing what that order is, then we go to the next class. So, is the order really important? Yes, it is, because if you don't, as you saw, different orders give different functions. It's not going to give you the same. And then there is a specific order that we have to follow to get to the final product. So, is the order of transformations important? Yes, it is, because wrong order will yield output wrong answer. So what is the order? The first order was, I'm going to use, let's say, green, is A, which gives me the reflection on the x-axis. Now remember, these letters can be different from other teachers. This letter can be different from your textbook, okay? Just to make sure that the location of each letter is the same. So for instance, a textbook uses K instead of B, but I told you that B is horizontally either reflecting or horizontal compression or stretch. So it actually is the same as K, and a simpler way of saying is that they are actually located in the same position. So remember that. Now A is reflection on the x-axis, depending on the sign of the A, and then at the same time it also gives me vertical stretch or compression by a factor of A. So remember, the by a factor of means that you're multiplying, and this A value is outside of the function, so that actually applies or affects the y value of it. So anything that's outside of the brackets affects the y value. Anything that's inside of the brackets affects the x value. Okay, so don't forget that. Okay. Now then, the second order is the b value, and b value actually is the reflection on the y-axis. So remember, the x-axis of rotation is actually flipping this way, the vertical way, whereas the reflection on the y-axis is the horizontal reflection, which gives me this way, right? And then it also gives me horizontal stretch or compression by a factor of 1 over b. Okay, so remember, we investigated why it's 1 over b, and it was explained in the class as well. So make sure that you understand why. Then third one is the c. This is the horizontal translation either to the right or to the left by C units. Please do not put HT and RL on your test, okay? I'm just putting this so that the video actually can be shorter. And the D is then vertical translation up or down by D units. Okay, so be really careful. Okay, be really careful. So I'm going to actually cross the 5, and I will put an extra example maybe. I'm saying if the y equals, let's say, f at x minus 3. Now in this case, your c is 3. Okay, it's not -3. C is 3. C is supposed to be x minus c, right? There's supposed to be x minus c. So c actually is just a 3. Now let's then take a look at the example. So in this case, we are dealing with the parental function of f at x equals square root of the x. Now for the square root of the x, make sure you use the x values of 0, 1, and 4, and 9. Remember, these numbers are the perfect square numbers, so that these perfect square numbers will cancel the square root sign, so that it's easier for us to plot them. So I'm going to plot 0, 1, 4, 9. So I'm going to use the green one, 0. Now when x equals 1, it is going to be at 1 because square root of 1 is 1. Square root of 4 is at 2, so it's going to be 4 comma 2. And then square root of 9 is at 3, so 9 comma 3. So your square root of, or the radical function, or square root function in this case, is a curve, not a straight line. Okay, but it only is a half, let's say. It's not really at the bottom. Then we have g at x as the negative f at 2x plus 2 minus 3, and hopefully you recognize it that this 2 is not factored out, so we actually have to write it with that one factored out. So it will be 2n x plus 1 and then minus 3. So then we can start with the first transformation. So I'm going to actually put this one down here. Okay, I'm going to put this one down here, and I'll just put it, this one is a g at x. So the first thing is the flip. So this is a reflection on the x-axis. That means all the y values are affected by this negative sign, meaning their sign changes to the opposite. So the 1, 2, and 3 becomes -1, -2, and then -3. So your graph will be, graph will be going this way. Okay, so again, remember this actually affects the x value. So sorry, y value. So the x values have to be the same. They have to stay the same. Now the second one that we're gonna do is the second thing that we see here, which is actually 2. So this 2 hopefully recognizes that this is the horizontal compression by a factor of 1/2. Remember, it's by a factor of 1/2. That means you're multiplying some value by half, so all the values are compressed, right? But in this case, it's inside of the brackets, so the x values are compressed by half. The x values are multiplied by half. Okay, so I'm gonna put the red graph just to compare from the previous one. So 0, 1, -1, and then 0, -4 and -2, and then 9 and -3. So that was our graph after the first transformation. So then the second transformation is with the blue, that every x values are in half. So 0 will still be the 0. 1 will be half, so it's a half at then 1. Then 4 will be at 2. So the y value is, so y value is still at 2, so -2. And then your 9 as the x value becomes 4.5, but the y value is still 3, sorry, -3. So your graph then actually looks like this right now. So the graph actually is not shifted, the graph is compressed sideways, okay? Now then the third one that we're going to do is the +1 in this case. So this +1 is the c value of -1. Therefore, it will give us the horizontal translation to the left by 1. So let's just draw the second transformation graph where it is at 0, 0, 0 0.5, 1, 2, -2, then 4.5, -3. So this is our second graph. So then our third graph will be moved to the left by 1, right? Left by 1. So all the x values will be moved to the left by 1, whereas your y values will stay the same. So it will be here, here, and then it will be 1 to the left, and then 1 to the left. So your graph actually looks like this. Okay, your graph actually looks like this, that they actually shifted to the left by 1. Then lastly, so I'm going to actually just put this one before we actually start the next one. So then we have this, and that, and then 3.5. So this is our third one, and now our final one, I'm going to use green again, or actually let's use the gray one. So let's actually use gray. So our final one is going down by 3. So we go down by 3. We go down by 3. So all the y values go down by 3. So it's at -3, -4, -5, and then -6. So our graph then looks like this. So at the end, it looks like this. So each graph, I actually want you to put the name of it, okay? So that I know what type of transformations you have gone through. So are we okay with this? Hopefully. Now then let's try the next one. So this one can be a little tricky. Okay, this one can be a little tricky. Now then we already talked about this, that this one is a little tricky to factor, but just remember that just rewrite this in a form of x starting first. So it will be -x plus 3 plus 1, but that means that it will be 2 and then -x minus 3 plus 1. So in this case, we have the horizontal reflection on the y-axis. So let's actually start graphing it. Now, some of you may ask me a question about what is this 2, right? What is this 2? What is this thing? Now, remember this. From 1 over x to 2 over x, all we have to do is we just multiply this by 2, right? But this 2 is multiplied outside, so this actually gives me the vertical compression or the stretch because it is outside. Well, in this case, it's 2, so it will be a vertical stretch by a factor of 2. So the first thing then will be this. For 1 over x, I told you that the x values that you have to use is -2, -1, -0.5, 0.5, 1, and 2. And each will give you a simple enough y values. Since it is 1 over x, you will never ever have the y value of 0. So your vertical asymptote is at y equals 0, sorry, x equals 0. And then your x value will never be 0 either, since 1 over 0 is the undefined. So you will have another asymptote at y equals 0. Now when x is -2, your y value is at -0.5, and then 1, and then 2 with -1/2. So your graph actually looks like this. And when you have 1/2, you should have 2, and then 1, and then 1/2. So your graph actually looks like, we examined this in the other class. So it looks like this. Now then it has to be flipped. So I'm gonna go a little faster since it's been a little too much time. So all the y values will be affected first. Remember that, right? This is actually the first one that we have to deal with. So this is the first. So all the y values are multiplied by 2. So the -2 now is at -4. 1 is at 2. And then 1/2 is at 1. So my graph now looks like this. So it actually is pulled down. and then this one is then at 4, and then 2, and then 1. So this one also is pulled up. Okay, so that vertical stretch by a factor of 2 actually affects both graphs. Now, then once you have that, so I'm going to actually put it as there, there, and then there. So this is my graph from the previous one. Hopefully you can follow. Okay, since they are the same color, it's easier for you to see. Then it's at 1, -2, and then -4. So this is my second half of the graph, where you have the asymptote at x equals 0, y equals 0 for this, and then you have the vertical asymptote at x equals 0. Now then the second transformation is flipping along the x-axis, so it is the reflection along the y-axis. So that means all the x values will switch their signs. So the 2 becomes -2, 1 becomes -1, half becomes -half. So your graph flips this way, right? So your blue graph actually goes there, and this blue graph actually goes here. So it will be at 2 instead of -2, -1 becomes 1, and then -1/2 becomes 1/2 for the x value. So that's how it works for now. Then the third transformation is then, so I'm going to actually put it here. So this was the second, all right? This negative sign there is the second. Whoop, whoop. So that was the second. Now the third one will be then -3 here, right? The third one is this -3, and then +1 is the fourth one. So -3 here means that C value is 3, so all of your x values will move to the right by 3. So I'm just going to put the previous graph here again, just to show you. So then we have at 4, 2, and then 1. So this is our graph going this way and that way, and it was also at 1, 2, and then 4. So this is where it goes with the asymptotes along, right? So the asymptotes are still there, asymptotes are still there. Now if you take a look, then we have to move to the right by 3. Now then you're gonna ask me, but Mr. O, your this graph then will actually cross the vertical asymptote. The vertical asymptote is not supposed to be touched by the graph. So good observation. Then your vertical asymptote will actually move with it. Okay, so your vertical asymptote being at y equals 0, it will actually then, sorry, x equals 0. Why do I keep saying y equals 0? X equals 0 will actually move to the side as well. So your new vertical asymptote is at 3. Okay, it was at x equals 0. Now it is at it is at x equals 3. Okay, so then all of your graphs actually will move 3 units. So 1, 2, 3. So it's there, and then it's here, then it's here. So this is now your new graph. However, your x asymptote is not going to move. Your horizontal asymptote is not going to move since it's not affected by this. And then this will also move by 1, 2, 3. So it's going to move 1, 2, 3, there, and there. So this is my third graph. Now then the last graph is then move up by 1. So from here, everything moves up. Then again, your bottom graph down here will cross the horizontal asymptote, and we're not supposed to. Well, later on you will actually cross it, but in this case it will only cross at the extreme value. So in this case, if it goes up, it's going to cross somewhere here. So then problem is, how do we make it not cross it? We move the horizontal asymptote together. Okay, so your horizontal asymptote is at y equals 0. Now then your horizontal asymptote is at y equals 1, since it actually moves up by 1. So this is now your horizontal asymptote, the new one, and this is now your vertical asymptote at x equals 3. So all of your y values will go up by 1. So then that means it is at, okay, so it is at here, and then it is at -1, and instead of being at -4, it will be at -3. So it kind of looks like this. Did I put the numbers right? Oh, it actually is here. So then this is my graph. Same thing with the top portion. So all the y values go up by 1. So instead of starting at 1, it will start at 2, and then 3, and then 5. So this is now my new graph. Okay. So the lesson was a little long. The video was a little long because I had to graph quite a few. But hopefully this helps you understand how to do them all together, especially with the actual graph. Okay. All right. See you in class. Please do not move on to the next one yet.